Comparing key features of all functions. So there's a little disclaimer up there. It says recall all the key features we have studied in previous units. If needed, refer back to those pages for notes. So we've done a lot of work with key features. Okay, so I'm not going to review every single type of feature. Hopefully you remember most of them. But here we go. Number 1 says 3 functions are graphed below. Answer the following questions based on the 3 functions. Okay, so it says, which function has an x-intercept of 2? Remember, x-intercept is where it crosses the x-axis. H of x has a, you don't have to write what I'm about to write. H of x has an x-intercept at 1. F of x has an x-intercept at -4. G of x is the one that has it at 2. G of x. G of x has the x-intercept at 2. B says, which function does not have a domain of all real numbers? So remember, domains are possible x values, which is like left and right, because the x-axis goes left and right. Now, H, this is going to go forever in the negative direction, right? And it's also going to go, it's going to continue to go this way as well because of this arrow. That H has a domain of all real numbers. This is asking which does not have a domain of all real numbers. So H is not the, H has a domain of all real numbers. Even G does because of these arrows. It's going to continue to go to the left forever. I know it looks like it's going quite vertically, but it's still going to go to the left forever. And this one's still going to go to the right forever. G also has a domain of all real numbers. The thing is, f of x doesn't. F, just right here, it's never going to go to -5, -6, -7. F of x does not have a domain of all real numbers. And it says, what is its domain? Well, the domain is only from -4 onward. So I'm going to say the domain would be when x is greater than or equal to -4. Okay. So its domain is only for x when x is greater than or equal to -4. It's only -4 and greater. Which function is increasing for all real numbers? So which one's increasing for all real numbers? Now this one's kind of tricky. Now G, remember you got to read these left to right. So I already said off the bat, H is increasing for all real numbers, right? If I read it left to right, it's always going up. So H of x. And you might think, oh, so is f of x. F of x is increasing the whole time, right? Increasing. It's going up. But here's the thing. It says for all real numbers. It doesn't even have a domain of all real numbers. It doesn't have, for -5, -6, and -7, it doesn't even go to that area. So it's not increasing for all real numbers. It's only increasing over the domain in which it has, which is when x is greater than or equal to -4. So technically, I wouldn't say that one's increasing for all real numbers. Only h of x I can say that. And then g of x, hopefully you recognize, you read it left to right. This is going down. This is decreasing. It's decreasing for all real numbers, actually. So I'm not going to select that. Which function has a range of all real numbers? Okay, that's a good question. So ranges are up and down are y. That answer is g of x. It goes up to positive infinity, right? It goes up forever. It goes down forever. This one has a range of all real numbers, g of x. Meanwhile, f of x doesn't. It never goes below the x-axis. Its range is not all real numbers. Even h of x, it has an asymptote here. It's never going to go below -2. So the only one that has a range of all real numbers that goes forever in the positive infinity direction for y and goes forever in the negative infinity direction for y is g of x. Which function has the smallest y-intercept? So let's look at the y-intercepts. H of x is at -1. F of x is at 2. G of x is at, that looks about, I think crosses there at 8. So definitely h of x. H of x is -1. So h of x, we'll pick that. Let me erase these dots. So h of x has the smallest. And then it says, what is the y-intercept? 0, comma, -1, I think it was. Which function does not have a negative interval? Remember, we're talking about negative. It's basically saying what's below the y-axis, or sorry, the x-axis. If it's negative, it's below the x-axis. So this one has a negative interval. It's negative here. This one never is negative, f of x. G of x is negative there, right? So the only one that doesn't ever have a negative interval is f of x. It never goes in the negative region. So f of x does not have a negative interval. G says, which function has an asymptote? That would be h of x. I think I talked about that a little earlier, right? Exponential functions have those asymptotes, so I'm going to say h of x. Where is it located? At -2. So that's the line y equals -2. H says, as x decreases, y increases for which function? Okay, as x decreases, that means we're going to the left. As x decreases, y increases. Okay, so which one, as x decreases, as we go to the left, does y increase? It goes up. I'm going to go with G for that. G of x. As x decreases, as we're going this way, going to the left, y increases. It's going up. So definitely G of x. Geez, that's tough. There's a lot going on there. So do your best on number 2. Okay. Do your best on number 2. All right, let me do a couple of these. Two functions are represented below. F of x as a table and g of x as a graph. Which function has the smallest y-intercept? What is that y-intercept? Okay, so it's just asking this. It's just saying which function has the smallest y-intercept, and then what is it? Now remember for g of x, the y-intercept is very clearly at 0, -6. Now the table is not always as obvious. You remember, when we're trying to find the y-intercept, we're looking when x is 0. So we're looking here. For f of x, it's at 0, -4. So which one has the smallest y-intercept? I would say g of x. Where is it located? G of x at 0, -6. Number 4, 3 functions are represented below. F of x is an equation, g of x is a table, h of x is a graph. Which function has the greatest x-intercept? What is that x-intercept? So now we're talking about x-intercept. Okay, remember the x-intercept is located when y equals 0. So for g of x, the x-intercept is at 6, 0. For h of x, it's at 3, 0. All right, so that's g of x and h of x. Now, f of x is a bit more of a challenge because it's an equation. So we're going to look when, I'm going to do it over here, when y equals 0. So I'm going to say 0 equals x squared minus 49. Now I'm going to solve this. You can either solve it by taking square roots or factoring it. I'm going to factor it. This would be x plus 7, x minus 7. So then set each equal to 0. Whoops. Subtract 7 from both sides, so -7, and then +7. So this one's quadratic, x squared minus 49. It actually has 2 x-intercepts. Like imagine, look at my arms. It's like down here, and then it makes a U. It's going to make 2 x-intercepts. And those two x-intercepts would be at negative 7, 0 and positive 7, 0. So which function has the greatest x-intercept? Right here. 7, 0 is the greatest out of all those. And that's function f of x at 7, 0. All right. I'll let you do number 5. That one's talking about y-intercept. Let me do number 6. This is important. This is an important concept. It says, consider the table for the linear function, quadratic function, and exponential function. Fill in the table for the 3 functions when x equals 7. Okay, so it gave us the functions. So when x equals 7 for the linear, now you could plug in 7 or you could just use the pattern. I'll just plug in 7. 25 times 7 plus 100 is 275. So I'm just using these functions here. And I'll just plug in 7 for the quadratic one. So 7 squared is 49 times 3 is 147. And then I'll plug in 7 for the exponential. 2 to the 7th is 128. So just needed to fill out the table there. Now here's the kind of important concept with these functions in letter B. It says for extremely high values of x not listed in the table, which function will exceed the others in value? The linear function, the quadratic function, or exponential function? So for extremely high values of x, which function will exceed the others? Which function will exceed the others, will be bigger than the others, exceed the others? Well, right now, the linear function is biggest, right? It's at 275 after when x is 7. The quadratic's at 147. The exponential is at 128. So the question is, which one's going to be bigger as we keep going? So maybe to best understand this, why don't I go to 8? So if I just went to 8, if I go up another, this is really just going up by 25s, right? So if I were to go up, this would be 300. Let's see how the quadratic one does. If I do 8 to the second power, 8 squared times 3, be 192. So that's still less. Now let's go 2 to the 8th power. That's 256. Whoa. So now it looks like the exponential is getting pretty close, isn't it? What if I went to 9? That would be 325. 9 squared times 3 is 243. And then 2 to the 9th is 512. So look at that. It looks like the exponential function, despite starting off so small, is suddenly surpassing both the other functions. And I could keep going to prove this fact even more. I mean, the exponential, we go 256, 512. I mean, it's just doubling, right? The next would be 1,024. Double that. Like, it's just going to keep getting bigger, keep doubling. It's going to keep bigger. The linear, although started off pretty high at 125, it's only going up by 25 each time. It's this exponential function that's going to exceed all the others. Now, the quadratic's growing. It's growing pretty fast, and it's going to exceed the linear function, I'm sure, but it's not going to mess with the exponential function. That exponential function is going to grow. So which function will exceed the others? The exponential function. And even if you wanted to, you could just plug in a large number of x. You plug in 15 or something and see how much bigger the exponential function is than the linear and the quadratic. So keep that idea in mind. Exponential functions grow so fast. I mean, heck, look at our parent functions that we dealt with. Like exponential growth, like it will just shoot up like really fast exponential functions exceed any other function. They really just blow up like that. Okay. So that would be the answer there. I'm going to let you kind of use that concept that hopefully help you understand number 7. So I'll let you do number 7.